Hello everyone, making this video for A341 pipeflow. Be showing you guys how to use Matlab to generate your plots. So let's go ahead and get started. You guys could follow along. I'm going to try to go a little quick, but you can pause it and go at your own speed to write the code using Matlab. So first thing, open up a new Matlab file. Have one open already. You want to add a few comments just for your own bookkeeping. It'll help you later on if you ever look back at this code. Typically, I look back at old codes now, and I try to make comments to help myself out if I want to pull certain lines of code instead of rewriting them. So we're going to be plotting head loss versus velocity, and we're going to want to calculate the least square fit lines for both of those plots. And this is going to be a log versus log plot. So first thing we want to always add CLC, which clears your working window. We want to clear all our data, and we want to close all plots that are open. It's typically used if you want to run your code multiple times. You don't want old data being pulled up. So we want to add some variables. I'm going to call HL for head loss. Add some brackets for now. It's going to be a certain size array. We're going to add velocity. Same thing. And Reynolds number. Same thing. So between these brackets, you're pretty much just going to want to open up your workbook. You're going to see your lab data is already completed, filled in. It's going to be posted up on Blackboard. You'll directly copy and paste straight from Excel into Matlab. Nice feature about arrays. They recognize Matlab to Excel or Excel to Matlab. Same with velocity and Reynolds number. You could type these in. It's easier to copy and paste. Here we go. So we're going to want to set up some counters. Why set up a counter? We want to separate laminar and turbulent flows and head losses. So we're going to set up some counters. J equals to 1 and K equals to 1. I didn't use I because we're going to use a for loop. So for I equals 1 to whatever the length of our Reynolds number array is, we want to do something. What do we want to do? Well, we want to separate our data based on laminar flow and turbulent flow. So literally we'll just write if Reynolds number of that array is less than 2000, we will put our velocity, laminar velocity, into some array based on our original data. I like using capitals. Make sure I stay consistent. Matlab does tell the difference between capital and lowercase. Same thing. So laminar head loss, J equal to head loss I, and all we've done is we've put our velocity into the first, column, row. It's only a 1 by however many length array, and we want to move to the next one. So J equals J plus 1. So now the second time it finds a Reynolds number less than 2000, it'll put it in column 2. We want to do the same thing for a Reynolds number greater than 2000 as well. All I'm going to do is just copy and paste this. Change a few things. Greater than 2000. Make this turbulent velocity and use K. Switch out all your K's. This is going to go into a separate array. Same code. Head loss turbulent. There we go. So all we've done, if we run this really quick, save it. And we're missing a bracket. Look at our work. That tells you line 36. Go up to line 36. Might need an equal sign. There you go. You can see in your workspace you have your original data, you have your velocity laminar, velocity turbulence, your head losses, your original head loss, your laminar, and your turbulent. You can see the size of these arrays, and you can check on your data. Double click it, it tells you what values went in there. It tells you some statistics, maxes and mins. All right. Let's go back to our code. Separate our data. Now we want to take the least square fit. As I said, I typically pull lines of code from my old code, so that's exactly what I'm going to do here. Least square fit actually is a simple line of code. There we go. It's built into Matlab. It's actually this polyfit command. So we're going to use polyfit. We're going to use the log of our laminar velocity and the log of our laminar head loss. And we're going to take a first order, so a linear least square fit. You could change that and make it a fifth order and so on. This second line, we're solving our equation. Log of head loss is equal to laminar head loss. Log of head loss, laminar head loss, is equal to the log of our slope times the log of our velocity plus the log of our b value. So essentially this is our k or ax plus b equation. Reason I use p1 and p2, if we run this really quick and look at our workbench, you'll notice that your slope is p1 and your b value is p2, or k value in this sense. Yeah, correct. P2 is k. P1 is slope. So, correction on that. So we will do the same thing for the turbulent code, or the turbulent points. Copy and paste it. Use turbulent here. Hold on a second. All right, so all we're going to do is change everything that says laminar to turbulent. There we go. So now we have least square fit for laminar, least square fit for turbulent. I like adding comments in here, just again for a later reference. Now we want to plot our data. So we have all the information. It's all in our workspace every time we run the code. So we're going to want to plot our original data first. So log plot of our x-axis is going to be velocity, and our y-axis head loss. And we're going to want to plot circles and the color red. Plot this really quick. Give it a second. There you go. There's your data points. As you can tell, there's a lot missing. You need legends, labels, point definitions, and your least square fit lines, and a title. So we'll go by really quick, and we'll do this as well. So we're gonna hold our plot on. We're gonna turn the grid on. We're gonna plot log of laminar head loss. We'll make this line dashed and blue. We'll do the same thing for turbulent. We will make this one black. And we should have 2 more lines on our plot now. There you go. So a few lines of code. You're going to have a title. You're going to have x-axis, y-axis. Just going to copy these directly from my other code just to save time. So title, x label, y label. There you go. There's your labels. A few more things we need. We need to number our runs and add a legend. So if you want to number your runs, you need to create an array with a string of numbers. Again, Matlab can do this. Copy and paste this. Once you've done it once, it makes it easy to do it again. Just copy and paste. So create labels. Use a self string based on a number string from 1 in intervals of 1 to the length of v. So however many points are in my velocity. I could have used Reynolds number here. I could have used head loss. Doesn't matter as long as all it's doing is going to count the number of points I have in my original data in intervals of 1. So if I wanted half, it'll do halves and so on. Here I want to add text. I want to add text based on x label of v, y label of head loss. I want to add labels, which is this array, at this location. So let's run it, see what happens. Got an error because I'm using HL instead of head loss. There you go. Points are labeled. Comes in very handy. Makes it look a little nicer. Next thing we want to do is add a legend. You want to create labels for your legend. So label 1 is equal to, label 2 is equal to, and my legend. So again, label 1 is my laminar slope. It's going to be equal to, and I actually can just call num2string. I can call this directly. We've already stored this, so I'm just going to call my slope. Could do the same thing for turbulent. Just going to copy and paste it. You'll see what happens. It actually just goes into my workspace, pulls that value and stores it, and then puts it on my legend. Again, I'm going to copy and paste my legend. So legend, my first legend is experimental data. My second legend is label 1. Third legend is label 2. Place it in the best location. Alright, what are we missing? Close brackets. Run our plot. You'll notice now there is a legend. Your points are labeled. Your lines are differentiated between laminar and turbulent, and you have your slope data. Your theoretical data says laminar should be 1 and turbulent should be 2. For this set of data, you could see, and now you could calculate your percentage error. You could actually just calculate percentage error in Matlab, or you can do a hand calculation as well, or use Excel. It's up to you. So this is what your plot should look like. You can just use File, Save As. Instead of saving it as a figure, you have multiple options. I prefer pete.png. It's a really good photo file, plus it imports easily into LaTeX. So pipeflow, or you can call it V versus H. V versus H. Save it. There you go. So that's the end of this video. If you have questions, comments, the notes are posted up on Blackboard. This should help you out as far as plotting. The notes cover what else needs to be included in your lab. You also need to plot your data friction factor versus Reynolds number on Moody's diagram. You need to determine the relative roughness, and you also need to determine your E factor, which will be based on the type of material. You have a table that shows you different E factors for different materials, and you can calculate the percentage error as well from your lab and the actual material. Your theoretical value for that E factor has also been given to you to calculate percentage error. All right, well, good luck. If you have questions, email me. And that wraps up this video.